Well, you were warned. We talked about how 2023 was going to be the year to see if mankind survives on planet Earth. We're talking about the ground temperature, surface temperatures all the time because radiation heats those up. This is a dashboard of a car in February, by the way. 197.7. What would that be like if it was really 115 out instead of 80? It would be very interesting. The sidewalk outside, 134 degrees, while the regular air temperature was roughly 80 degrees. That's significant. And again, we talked about how radiation doesn't heat the air, but it heats water and it heats solid things. And that's pretty high, 134. When we go to the asphalt, which is black, 145.5. So, yeah, you can start cooking. Put your skillet on that asphalt there and start cooking. So the difference between the asphalt and the concrete is about 20 degrees. But what a huge difference from the air temperature. I mean, 80 degrees. Well, this is what's happening all over the world. This is sea surface temperatures, and we can see how there's an accelerated trend to these temperatures. These are surface temperatures. Now, if we were to plot atmospheric temperatures, the graphs would be all over the board. But this is the most telling thing: sea surface temperatures. Because water absorbs 80%, 90% of cosmic and solar radiation. And you were wondering why the sun was white. This is a proof that when you mix, get this, when you mix yellow light with blue light, you get white light. It's not the same as mixing colored paints. Blue light comes from electrons. And then we were talking about where the radiation's coming from. We've proven it. We've connected every single dot in this Planet X mystery. We've tracked it through the entire solar system, and now it's left its evil dust within our solar system. It's still affecting the plates. It's still affecting tectonics. It's still going to be slinging even more comets. You think the comets were thick? They're going to get thicker as this thing approaches the Kuiper Belt. But the helium charge exchange, it talks about in this article about how intense it is when helium loses an electron rather than when hydrogen loses an electron. When helium loses an electron, the energy that's created is 250 times higher than hydrogen. So helium can pack a punch. And if it has all its electrons, then you're talking about a lot of electron activity, because there's 2 electrons on every helium nucleus, where hydrogen only has 1. So this interaction of these particles, they're everywhere, and we know they're from Planet X, but look at the temperature difference. This comparison is conservative. So this is minimum temperatures, but this shows you how hot you can make the ground. And literally at 140 degrees, in 5 seconds you can create a stage 1 burn, blistering. But the heat in the car is even greater. And you saw where the dashboard was 195. So they're reporting it could get up to 140 degrees. Well, you can see we're already starting to blow those averages, those recorded scientific fact of these higher temperatures for solid objects, they're going through the ceiling. 197 on the dashboard, and yet they were warning you about how the car could get to 140 degrees. No wonder police dogs have been dying in their cars with the air conditioning on, by the way. So I'm going to attach a link to another video by a friend on YouTube who went out during a geomagnetic storm and started taking temperatures of solid objects. And the solid objects were much hotter on the day of the magnetic storm, but the air temperature really didn't vary hardly at all from one day to the next. And even though you can't rely on what they think the solar irradiation was back in 1700, they think they know because of the sunspots, but it does seem that solar radiation is on the climb. We've showed you how the baseline for the high energy X-rays in blue, we showed you how those were 10 to the minus 9, a whole exponent lower just a couple years ago. Now they're 10 times higher, and we're telling you in another year it'll be 100 times higher than this. The high energy X-rays will be above the 10 to the minus 7 line. And cosmic rays hit a space age high. We were warning about these cosmic rays long before this article even came out. And so when mainstream science validates what we've been telling you, and we've been telling you a year or two in advance, then I would think that vindication would then allow you to have some trust in our credibility in our reporting. This graph on the upper right is iron. Yes, iron as an atom, as a cosmic ray, flying through the atmosphere at 5,000 to 10,000 degrees Kelvin. Yeah, where is the iron coming from? I wonder. Iron cosmic rays. Well, maybe we had a brown dwarf collide with an iron planet, and now we have hybrid objects coming into our solar system. The heat is so phenomenal that even on the heat map, they are giving us spooky faces. Spooky, creepy little faces on your heat map. And the helium. I found a half dozen graphs of all these cosmic rays and how just by the images produced by astronomers, scientists, NASA, JPL, all of these people have made their own representation of the cosmic rays, how they are acting in our solar system, and they all show that the neutral cosmic rays get focused in gravitationally. Anything that has a mass cannot withstand gravitation unless there's an anti-gravity component. So they call it interstellar medium, like it's coming from the stars, but it's in our own solar system. And they shows as like a wave or like a cloud moving in, but yet the focusing cone is very well defined. That arrow on the left is a really good indicator that the helium isn't a cloud, but it's a stream, and it's coming from one direction only, and the focusing cone has been very, very narrowly focused, which means we can't be in a cloud, because then we would be pulling it in from all sides instead of just one side of the solar system. But look at the upper right. It says helium, oxygen, primary stream, oxygen secondary stream, interstellar gas trajectories, interstellar wind. There's other things in that wind other than just helium, but they're remnants of an old and big, big star like a red giant. Again, another narrowly defined helium focusing cone brought to you by scientists who say, I don't know what I'm talking about. This has led to geoengineering. One day you look up in the sky and there's dozens and dozens of lines in the sky making X's and crosses and triangles and all kinds of things. And then they kind of form a haze that blocks out the sun. Okay, if you don't think they're geoengineering, there's no hope for you. I'm not trying to be insulting, but it's so obvious. And anything that obvious, if it's escaped your observation, something is wrong. Something is just wrong. Now, the heating of the ground triggers other things that could spell a one-way ticket to extinction. The release of methane and high methane levels are associated with several of our mass extinctions. And methane has been going through the roof. We thought it hit its tipping point in about 2007 when it started to make its sharp little curve. And since it made that sharp little curve, which we think was the tipping point, well, the point of no return for methane, even though we've reached that, can you imagine how accelerated that curve had become? I could have never imagined, but this accelerated curve kind of matches other accelerated curves. And if you think somehow Planet X is crazy people talk, just know that a science magazine on page 2488, talking about space probes, has a diagram of the Pioneer and Voyagers. It also shows you a dead star and the 10th planet. Or is it the 9th planet? What's that doing in a science encyclopedia? And we knew what was going on when this thing we said was passing under both Saturn and Jupiter. They both got new moons traveling roughly in the same direction as Planet X, and in the opposite directions of all their other moons. Yes, Jupiter picked up moons too, traveling in the wrong direction. All of these have very steeply inclined orbits. And all the volcanism, if the volcanism on planet Earth was related to Planet X, then any other object in the solar system with volcanism would show a dramatic increase in that object's volcanism. I'd like to introduce you to Io. Io. So it's crazy, but it's true. And survival is key, and having backup water, having backup food is always a good strategy, unless they put handcuffs on you and haul you off somewhere. But the waterbed scenario is a great scenario if you don't have the money or the ability to store a large quantity of water. I mean, if you have a swimming pool, and it's full, that could suffice, yes. But if you live in an apartment, putting waterbeds, just a true waterbed mattress without compartmentalization, put that in your apartments and sleep on those. And if worse, if you get into emergency, you would drink that water through a filter. Now, if Planet X was real, I mean, we looked for every single symptom that you could predict. What could you predict would happen if a large or small brown dwarf, a brown dwarf fragment, came racing through our solar system in a retrograde orbit opposite of the planets and inclined? What would happen? And we got a bunch of new comets. Yes, new comets. And they have to be there. Why do they have to be there? Because Planet X was there. They would have to be there. Planet X just can't pass through the Kuiper Belt and come through the asteroid belt without slinging debris everywhere. Now, this has caused many earthquakes. The earthquakes upon earthquakes. Earthquakes then can disrupt your magma chambers, and earthquakes send sonic waves and electromagnetic waves and all kinds of waves through these magma chambers, creating expansion of those magma chambers, and then volcanism goes through the ceiling. The reason I'm showing you this is because this is how active the Tonga Trench was before the major explosion, the largest explosion in modern day history, and incredible. And we called it a super caldera. We called Tonga a super caldera, and people just really couldn't fathom what I was saying. But when you look at the underwater map, you can kind of see a caldera that's about 40 miles by 50 miles. And then again, the methane accelerating, not rising, accelerating. So when something's accelerating, think about a point of no return with two magnets. You're slowly moving one magnet closer to the other until they latch onto one another. And then look how quickly they accelerate towards one another. You can't keep them from accelerating. There's a point of no return in your acceleration curve. Now, one of the sources of really high radiation, the gamma radiation, is called the Compton effect, and some people call it the inverse Compton effect, where an incident photon strikes an electron. Here they use it at rest so that the math adds up. But can imagine a photon and an electron running into each other and creating gamma radiation. If we have extra electrons, then we have to have extra gamma, and we do. Every single symptom of a brown dwarf is present, and it has to be. Well, if one of those symptoms do not exist, then there can be no brown dwarf that comes through our solar system. But you know, the temperature swings and the acceleration is frightful. And we showed you how whenever we got into special alignments with this brown dwarf, that it threw off the whales. And every major whale and dolphin stranding, you go back and you look at the planetary diagrams, there will be an alignment involving Earth, Planet X, Jupiter, or Jupiter and the Sun. And you throw Venus in there, kind of complicates it. So these total solar irradiance without the background being calculated shows you a huge increase in amplitude. More particles, more radiation, heating the land. Now, well, the volcanism is of concern for some people because they live near volcanoes. And frankly, the United States is nothing but a volcanism everywhere. And we called the Great Basin a super mega caldera. We're the only people on the planet Earth and the first people on the planet Earth to call the Great Basin a super mega caldera. And then, you know, lo and behold, they did a survey that you looked through the ground. I don't know whether it was sonar or high power x-rays, but they determined a lot of liquid carbon underneath the Great Basin. And how did we figure out the Great Basin was a super mega caldera? Number one, there's too many supervolcanoes along the edge of the Great Basin. And the ones in Albuquerque simply rotated away from the Great Basin. And the Colorado Plateau was built by volcanism and therefore kind of obscures what used to be there. another basin. So, when your basin grows mountains, it doesn't look like a basin anymore. So, a lot of the Great Basin that extended into Colorado and into New Mexico, doesn't look like a basin. It looks like a very high plateau right now. But anyways, so we were right about that. And the other thing is, right in the heart of the Great Basin is Nevada. And I'll have you know, Nevada has more hot springs than any other place on planet Earth. We're not talking geysers, we're talking hot springs. And all along California, the Central Valley, all the way up to Oregon and the volcanic fields, okay, there's nothing but hot spring after hot spring after hot spring. And you see clusters of earthquakes anywhere along California that aren't related to the San Andreas Fault. Those are all occurring near a hot spring. Almost every single earthquake cluster. So then we look back at the past extinctions, and we're finding out more and more about these past extinctions. We're actually starting to see that there was high levels of radiation during some of these mass extinctions, and we're finding more and more craters, impact craters that were huge, that could have contributed to widespread global climate change. But almost all of the great extinctions involve climate change. And the pattern of the extinctions, when you look at the patterns, is you have heat followed by cold. The heat comes from the radiation created by Planet X. The cold comes from the increased volcanism, which kind of saves the Earth from cooking for too long. And when we got downstream on this instrument, this measures one thing, helium, and the below the line in the middle is the higher energy helium. And look how concentrated and narrowly defined those concentrations are at those energy levels. Then go to the above the low energy helium, which is neutral, and you see a widespread dispersion of that helium, meaning that it's not coming from the sun, it's coming from out in the solar system. Again, accelerated curves to everything. And when we do talk about impacts, I wanted to point out how there's a vertical alignment to the major impact sites. Just north of Arizona's famous meteor crater, there's a crater in Utah. I mean, these craters are meteorite craters that left significant damage to the local area. They almost land on top of one another, but yet could be hundreds of thousands and millions of years apart in age. So a million years, another meteor hits really close to another place, like lightning striking 2, 3, 4 times. Well, that's because the magnetic field lines pull these things in. And they pull them down along the magnetic field lines, focusing them in to certain areas. Now, when you talk about all the volcanism, and you talk about all the earthquakes, this map, which is put together by students that were studying the GPS and all of the data on the plate movements, and found that the original movements of all of our floating plates on planet Earth had changed. Almost all plates had changed not only speed, but direction. All the plates. So what could do that to planet Earth? And that would be an outside object exerting tidal influence, creating earthquakes. Now you know why we have so many earthquakes. You change the direction and the speed of your plates and your plate boundaries are going to be shifting. The radiation maps from 2003 to 2017 show huge increases in energy, even though we were going into a solar minimum. So what's going on is that helium and the oxygen and the carbon and the electrons are being focused into the corona of the sun, where they ionize and release incredible energy. Lithium is part of that. And this is a lithium spectrum, by the way. Lithium is a sure sign of a brown dwarf. All brown dwarfs contain lots and lots of lithium. So then what happens? All that radiation heats the ground, the permafrost starts to melt, and what you have to know, just in the permafrost, nowhere else, just in the permafrost, the shallow permafrost, there's enough methane to double, that is double the concentration of what's currently in the atmosphere today. So you could then literally, if you let go of all your permafrost methane, you could triple what the methane level is. But I got even worse news for you. Underneath the shallow permafrost are larger reservoirs of older methane, and those are leaking up through the permafrost lakes that are forming on the permafrost. So we're not counting the caltrates. We're not counting any of that, which gigatons there. We're not talking just about what's trapped in the deep oceans. We're not talking about any of that. So literally, it's possible to trigger enough methane to put our atmosphere 5 and 6 times its current concentration. And that curve is accelerating. It's accelerating. And methane is associated with almost all of our mass extinctions. So all the evidence is there. We explained why we're having changes in the ratios of electrons to protons. We were showing you how helium can create beryllium, and helium can create lithium, and how lithium and helium can absorb protons, and that's why our proton counts are so low. And if you don't think it's the cosmic rays that are causing the 190 degree temperature on the dashboard of somebody's car, if you don't look at this graph, now some very bright people actual measured the neutral helium and then plotted it against the cosmic rays, and they found that the neutral helium really kind of mimicked the cosmic rays. But which also mimicked that were the surface temperatures, not air temperatures, surface temperatures. So when you plotted the surface temperatures against the cosmic ray counts, we saw a pretty darn good correlation. This graph in itself, if you could trust the raw data that created the graph, because all that data came from astronomers and satellites, then what they're doing is proving to you in this graph that cosmic rays are related to the heating. And everything is an accelerated. Greenhouse gases accelerating, methane accelerating. The only thing that's not going up is the lower right hand graph. That's oxygen. Oxygen is going down. Now, plankton accounts for 70% at least of global oxygen. So if your oceans die and your plankton die, then we will die. So, and one of the most frustrating things about bringing all of this great news to you is that nobody was really paying attention to the volcanism. Now, the volcanism can save the day. Volcanism could cool the earth, put particulates in the airs instead of all those airplanes that are flying and cool the earth naturally. Water. The more you heat the ocean, the more evaporation, the more clouds. That cools the earth. So Earth is battling and struggling to keep its temperature from running away. But that methane is already the cat out of the bag. It's the fuse that's already been lit. And how do you stop it? How do you stop that fuse? But the volcanism was very frustrating. So we made a video a few years ago to try to get your attention about what was going on with all this volcanism, to try to shake people up. So here is some of that video. And